endless possibilities of nuclear fusion in the future. Imagine a world where energy is abundant and cheap, where power plants are small and decentralized, and where carbon emissions are a thing of the past. Nuclear fusion technology could provide a clean and limitless source of energy, allowing us to power our homes, cities, and industries without any harm to the environment. The potential benefits of nuclear fusion are truly endless, and it is no wonder that scientists and researchers are working tirelessly to unlock its full potential. Hi, welcome to the channel. Join us as we explore the endless possibilities of harnessing this powerful technology. So what exactly is nuclear fusion? Nuclear fusion is a process by which atomic nuclei come together to form a heavier nucleus, releasing a large amount of energy in the process. This is the same process that powers the sun and other stars, and scientists have been working for decades to harness this energy for use here on Earth. The main challenge in achieving nuclear fusion is creating and maintaining the conditions necessary for sustained fusion reactions. These conditions include heating the plasma to extremely high temperatures and confining it using powerful magnetic fields. The plasma must be confined long enough for the nuclei to fuse together, releasing energy in the process. One of the main advantages of nuclear fusion is that it has the potential to be a virtually limitless source of energy. Unlike fossil fuels, which are finite and will eventually run out, the fuel for nuclear fusion, typically isotopes of hydrogen, can be easily obtained from seawater and will not run out for billions of years. Additionally, fusion reactions produce no greenhouse gases, meaning that it is a much cleaner and more sustainable source of energy than fossil fuels. But how is it different from nuclear fission? Nuclear fusion is a highly advantageous form of energy generation compared to nuclear fission, which is currently used in most nuclear power plants. Nuclear fission involves the splitting of a heavy nucleus into lighter nuclei, releasing energy but also producing radioactive waste. In contrast, nuclear fusion reactions involve the fusion of nuclei. The resulting waste from this reaction is only a small amount of helium gas. This greatly reduces the risk of accidents and meltdowns, as well as the amount of radioactive waste produced. Additionally, the radioactive waste produced by nuclear fusion has a much shorter half-life, making it less hazardous over time. Overall, nuclear fusion is a safer and more environmentally friendly option for generating energy. Nuclear fusion, the process of joining atomic nuclei to release energy, holds great promise as a source of clean and sustainable energy for the world. However, the technical complexities of creating and maintaining the conditions necessary for sustained fusion reactions have hindered its widespread implementation. Despite this, scientists and engineers continue to make significant strides in advancing the technology towards commercialization. With ongoing research and development, it is expected that nuclear fusion will play an increasingly important role in meeting the world's energy needs in the future. There are currently several different approaches to nuclear fusion being developed around the world. One of the most promising is magnetic confinement fusion. It is one of the main methods being researched for achieving sustained nuclear fusion reactions. In this process, a plasma of hydrogen isotopes is heated to extremely high temperatures and confined using powerful magnetic fields. This creates the conditions necessary for the atomic nuclei to fuse together, releasing energy in the process. One of the main advantages of magnetic confinement fusion is that it is a relatively safe and clean form of energy generation, producing minimal waste and no greenhouse gases. It has a wide range of applications in the field of energy production, space propulsion, medicine, and material science. This approach is being developed by the International Thermonuclear Experimental Reactor (ITER) project, a collaboration between 35 countries to build the world's first fusion power plant. It is also an ideal energy source for the future, as it is sustainable, low cost, and produces no emissions. Nuclear fusion is not only a promising source of energy for Earth, but also a crucial component in space exploration. The intense heat and pressure required for sustained fusion reactions can be replicated in a spacecraft's engines, providing a powerful and efficient means of propulsion. Nuclear fusion propulsion systems can also be used for long-duration missions, such as traveling to distant planets or even other star systems. The energy produced by nuclear fusion can also be used to power spacecraft systems, such as life support and communication systems. Additionally, nuclear fusion reactions can also be used to generate isotopes that can be used as fuel for spacecraft and other applications in space. In summary, nuclear fusion technology has the potential to greatly enhance our ability to explore the depths of space and pave the way for future manned missions to other planets. With the ability to generate massive amounts of energy, nuclear fusion could be used to power weapons and vehicles that are currently not possible. For example, fusion-powered aircraft could potentially have unlimited endurance and range, while fusion-powered tanks and naval vessels could have greatly increased mobility and firepower. Additionally, nuclear fusion could be used to produce isotopes for use in medical treatments and radiation therapy, as well as in the production of nuclear weapons. Furthermore, the compact and lightweight nature of fusion reactors means they could be used to power satellites and other spacecraft, allowing for extended missions and expanded capabilities. Additionally, fusion-powered unmanned aerial vehicles, UAVs, could be used for reconnaissance and surveillance, as well as for delivering payloads to remote locations. In short, the military applications of nuclear fusion are vast and varied and have the potential to greatly enhance the capabilities of the military in the years to come. But it could also be utilized in the creation of nuclear weapons that could cause catastrophic damage if used in warfare. This emphasizes the importance of thorough regulation and monitoring of nuclear fusion research and development to guarantee that it is only utilized for peaceful purposes. The world is facing an urgent need to combat climate change and reduce greenhouse gas emissions, and the shift to clean, renewable energy sources is imperative. Nuclear fusion is an attractive option as a clean and sustainable energy source. Unlike traditional nuclear power, which is based on the process of nuclear fission, nuclear fusion does not produce any harmful greenhouse gases or radioactive waste. The process of nuclear fusion involves heating and confining a plasma of hydrogen isotopes, creating the conditions necessary for the atomic nuclei to fuse together and release energy. Nuclear fusion offers the potential for virtually limitless energy production, as the fuel required is abundant in seawater, making it a sustainable and renewable source of energy. With continued investment and research, nuclear fusion has the potential to become a major contributor to the fight against climate change. The pursuit of nuclear fusion as a source of energy has been ongoing for decades, and despite the significant technical challenges involved, scientists and engineers are making steady progress in developing the technology needed to achieve practical nuclear fusion. The challenge of achieving sustained nuclear fusion reactions requires solving a complex set of problems, including heating and confining the plasma, preventing the loss of energy due to the instability of the plasma, and designing a sustainable and efficient system that can be used in power plants. Furthermore, compared to nuclear fission, which is currently used in most nuclear power plants, nuclear fusion is a much safer form of energy generation. The risks of accidents and meltdowns are greatly reduced, and the waste produced is much less radioactive and has a much shorter half-life. This makes nuclear fusion a more environmentally friendly and sustainable option for generating energy. In conclusion, the possibilities of nuclear fusion in the future are truly endless, from providing an infinite and clean energy source to revolutionizing transportation. The potential benefits of nuclear fusion are truly staggering. Not only does it have the ability to provide us with a sustainable future, but it also has the potential to create new technologies and industries. The possibilities of nuclear fusion are truly exciting, and it's important that we continue to invest in and research this technology to unlock its full potential. With the ongoing advancements in nuclear fusion, the future is looking bright, and we can look forward to a world powered by clean, sustainable energy. Thanks for watching till the end. What do you think about the video? Let us know in the comments, and don't forget to subscribe.